Good morning. I hope everyone had a great weekend. We're going to be starting to learn about the Pythagorean Theorem this week, and that's going to be what our main topic is for the whole week. So if you don't really understand fully the lesson today, we're also going to be going over it again tomorrow. And just a reminder, please pause the video at any time when you think I'm going a little too fast, and then rewind, rewatch, so you can really understand all the information. You're going to see this again next year in high school, so it's important on a more deeper level. So it's important to learn about Pythagorean Theorem so you're not overwhelmed when you get to high school next year. Okay, so the essential statement for today is I can use the Pythagorean Theorem to find the unknown side of a right triangle. So we're going to start off with a definition. I know it seems pretty long, so like I said, pause the video and write it down in your notebooks. So the Pythagorean theorem states that the area of the square whose side is the hypotenuse is equal to the sum of the areas of the squares on the other two sides. You're like, what the heck? That doesn't make sense. All right, so I'm going to show you what it would look like on a right triangle. Remember, these are only right triangles. So algebraically, what this looks like is that I have a squared plus b squared equals c squared. So I'm adding the sides of the legs, the squares of them, and that equals what c squared is equal to. And there's also videos, and I know how to show you why that works, but we're just going to assume it does work, unless you want to look it up, or you can ask me later. But that's what the Pythagorean theorem states algebraically. That's what we're going to be working with. In words, it means leg squared plus the other leg squared is going to equal the hypotenuse squared. And so if you look at the diagram, which is probably going to be the most sufficient way to explain it, as you have this first leg right here, and we square that, plus the second leg right here, and we square that, is going to equal the hypotenuse. So what the heck is the hypotenuse? And the hypotenuse is the side opposite the right angle, and is also going to be the longest side. So visually you can see it's the longest side, and you also know it is opposite that right angle. And like I said before, the Pythagorean theorem only works with right triangles. It's not going to work with any other triangles. So you can only use the Pythagorean theorem when you see this little square here indicating that it is 90 degrees and a right triangle. Okay, let's get into some examples. All right, so my first example, and like I said, please pause the video so you can write this down. The definition and everything right here is super important to understand for today. Okay, so the first thing that you want to do is find the hypotenuse. And even before that, let's write out the equation. So I'm going to write it out in words this time. So I have leg squared plus the other leg squared is going to equal the hypotenuse. I'm just going to abbreviate hypotenuse squared. Okay, so I'm going to try to find my hypotenuse first and kind of fill it in from there. So my hypotenuse is the side opposite the right angle and the longest side. So opposite the right angle is going to be C. All right, we'll just fill in C squared here. Now, it doesn't matter which leg you put here or which leg you put there, it just needs to be different. So I'm going to put 4 squared here plus 3 squared here. All right, and then we solve for our variable. So 4 squared. 4 squared, remember, if we have anything squared, all it is the number twice. Right? When you multiply it together. So 4 squared is just 4 times 4, which is 16. And then you have 3 squared. And 3 squared is just 3 times 3. 3 times 3 is 9. And we'll keep our c squared going. Now 16 plus 9 is 25. Right. Then we have c squared. Now is c by itself? No, it has this little squared on it. And the way to get rid of a square is to square root it. So we talked a little bit at the beginning of the year about square roots, and I'm going to have a, a picture of what perfect squares are attached to your Google Classroom today. But to get rid of this little 2 right here, this little root, we need to do the opposite. So the opposite of a squaring is square root. So we have this radical symbol right here that gets rid of this 2, okay? And remember, whatever we do on one side, we also do to the other side. So we don't have the square root, we don't have the squared here, so all we're left with is c. And remember, 25 is a perfect square. So perfect square means that the 2 numbers multiplied together is going to equal what's underneath the radical. So what 2 numbers that are the exact same equal 25? 5. So that's why our answer is c is equal to 5. Okay. We're going to get to multiple more examples if you're still a little confused, and we're going to keep moving on to the next 2. Okay, so I'm going to write out the equation first with a squared plus b squared equals c squared, right? That's our Pythagorean theorem. And we're going to start filling it in. So let's start with what c squared is. Okay, remember c squared is the opposite from the 90-degree angle. So that is going to be 10 squared. Now we need to worry about the legs. So these would be the other legs. So I'm going to start with 7. Oh, let's work with just the a's. So I just have a squared plus 7 squared. Okay. Now, we now just have a squared plus 7 squared, and 7 times 7 is 49. And then we have 10 squared. What is 10 times 10? 100. All right, we're kind of have a couple 2-step equation here. So, how do we get a by itself? We need to find the side with the variable, find the number not attached to the variable. So the number not attached to the variable is 49. From the opposite operation, we subtract 49. Whatever I do on one side, I also do to the other side. So then I have a squared equals 100 minus 49. And that is 51. Okay, now to get rid of our square root, or to get rid of our squared, we need to square root it. All right, so we put our radical above, that gets rid of the square. And whatever we do on one side, we also do to the other side. All right, now, is 51 a perfect square? You can kind of look on the sheet that I'm going to provide for you and notice it's not a perfect square. Can we break it down and see if we can put a perfect square in there? No, we cannot. So what we're going to do is either you can plug it into your calculator and it'll give you a decimal, or you can leave it as a square root. So we're just going to leave this as a equals the square root of 51. Now if I were to put it into the calculator, I could get it as 7.14, which is fine, but you can also leave it as a radical. So you just have to follow the directions on what it tells you to do. Either leave it as a radical or put it into decimal. All right, last one. Okay, so I'm going to first start out with my equation. So Pythagorean theorem states that a squared plus b squared equals c squared. Okay, now we want to find the hypotenuse first. And remember, the hypotenuse is across from the 90-degree angle. Oh, So it's across from the 90-degree angle. So my hypotenuse is just C. And you know, sometimes it might have different letters like X or M. The variable is not always going to be A, B, or C. So I'm just putting that out there. Now we're going to look at the legs. So A squared would be 2 squared. I put that here. And then 6 squared. Okay, so we then just square the things that we can square right now. So 2 squared is 2 times 2, which is 4. And then 6 squared is 6 times 6, which is 36, is equal to C squared. All right, now we add 4 plus 36 is 40, equal to C squared. Now remember, we need to use the square root to get rid of the squared, right? So that's always going to be your last step. So we're going to square root. When you get to this part, in order to get C by itself, you've always got a square root. Okay? Now you might think, oh, we're done. We've got our 40 here. It's not a perfect square. What we can do is break down the 40 into something that does have a perfect square. So it's got a factor that is a perfect square. So I can break down 40 into 4 and 10. And we would write the radicals of the square root of 4 times the square root of 10. And we know that the square root of 4 is 2, right? Because 2 times 2 is 4. So it would be 2 square root 10, and that's what C would equal. So I'm going to have a list of what perfect squares are attached to your Google Classroom assignment for today. And that's the biggest thing, is just finding those square roots and those perfect squares. And we're going to obviously be going over more of this tomorrow, so if you're still a little lost, please pause the video and rewind it and write down. It's really important that you're going to be writing down this right here for your classwork today. Again, we're going over this tomorrow, and I'll talk to you guys then. Bye!